Hello everyone, this is Udit again from Tech Spark with another session. And in the previous session, we covered the fundamentals of the EMR. We went on to the theoretical concepts of EMR. And in today's session, we're just gonna head off to the AWS console and set up a cluster using the EMR service, then run a Spark Summit job. So let's get to the AWS console, and this is how the homepage looks. I mean, it's similar when we saw at the time of S3 bucket, but the only difference is now I'm going to be choosing EMR instead of S3. So there are a couple of ways you can do it. Either you can pick it from this recently visited services, but if you have nothing, in that case, just simply go here and type EMR and then click on it. So you land onto this clusters page, and this clusters page will list all the clusters that you have previously created. So you can see I created this one cluster previously and a couple of other clusters which kind of like terminated because of the wrong IAM role. So what I'm gonna do is I'm gonna create a new cluster by cloning this one. So either you can clone one of your existing cluster, or you can simply click on create cluster. So for the ease of doing things, I'm gonna pick cloning the cluster. I mean, it's not gonna be a huge difference. When you click on the create cluster, you'll still land onto this page. Okay. The only difference is it is already these things are picked for me, whereas you would have to just tweak these configurations by yourself whenever you're clicking on the create cluster for the first time. So this is the EMA release version. So I'm gonna pick 6.15. There are updated versions as well, but I'm just gonna go with this one. And then these are the tools of the applications that you can allow to be done in your EMA cluster. So for the moment, whatever by the default which comes up, that is the DB, Spark, Hadoop, Hive, and Jupyter Enterprise. So I'm just gonna keep it as it is. I'm not gonna pick anything else or kind of like remove anything. It won't matter much because this is just a demo, and afterwards I will simply shut off my cluster. And then here is the cluster configuration. So so whatever other settings are there, I'm just going to keep as it is. And when you click on the create cluster tab, these things will automatically be clicked for you. Okay, just go with the default settings, whatever there is. So coming to the cluster configuration and the instance group. So I did mention about two different kinds of instance group, right? One is the instance fleet, that is the hybrid of on-demand and spot prices. And the other one is the uniform instance group, where there will be only one on-demand or spot, any one you choose, and accordingly all the nodes will be like that. Okay, so I'm not gonna pick instance fleet, even if it is much like cost efficient, because it's just for some time I'm creating this cluster, so it won't matter much according to the cost. So I'm gonna pick the instance group, and by default this is the one that is already selected, and these are the different nodes, right, that is available to you. One is the master node, then there is the core node, and then there is the task node. So primary node is also known as the master node. So whenever you're trying to create a cluster, at least one master node you have to pick. If you choose you want to neglect the code and the task, that is fine, but at least one master node you need to pick in order to create a cluster. So for this purpose, I'm gonna pick like one node from each, from master, from core, and from task, so that it will give me a feel of a real-time cluster, right? One node is not really a cluster. At least like 3 to 4 nodes should be there in order to make it look like a cluster. And if you see that I'm choosing the M4 large, it has 2 CPU cores and 8 gigabytes of memory. So my cluster overall will have 8 cores, sorry, not 8, 6 cores, and 8 into 3, that is 24 gigabytes of RAM. Okay. And if you see the pricing over here, on-demand price is around 105 per instance, whereas the lowest spot price would be almost like half of it. Okay. So I'm gonna pick this one. I feel this is uh, much cheaper than the others, and accordingly, I'm also picking a substantial amount of cluster resources. Okay, so now coming into the there are other configurations as well. You can set the cluster size manually. You can highlight over here if you need more than one core. You can simply increase the numbers, but I don't want that. Okay, because I only want one core and one task would be enough for me. Otherwise, you can use the EMR managed scaling. So you would be provided with options like minimum cluster size, maximum cluster size, and accordingly, whenever the cluster feels that the cluster is overloaded, it will try to expand or do a horizontal scaling. And also, there's some custom automatic scaling where you can define the different threshold values using the cloud working fix. Okay, so I'm gonna use the set cluster size manually, and I'm just gonna pick one for each and every core and task node. And these are the default VPCs that are there. I didn't like do anything over here because VPC is a networking domain, and I mean we the developers, so we the data engineers, not required to have networking knowledge. So all this will be whenever you get into a project, everything will be set up by the admin team. No need to worry about that. Okay, so now we're here. Okay, so there's one more important thing is that whenever you create a cluster, so you have to log into it, right? And in order to log into it, you need a key file. A key file is nothing but a .pem or .ppk file. So what will happen is that your master node, okay, it will have a host IP, and to access that host IP, you will have to create a key pair value .pem file. So that using that .pem file, you will be logging in. Okay, how to use the .pem file while logging in, I will show you at the time of logging in. But for the moment, I have already created one, so that's why I'm using that one. WP. Otherwise, you can simply just click on the key pair and create it by yourself. So once that is created, you can just create a key pair and it will be downloaded into one of your local machine folders, and you can use it while logging in. Okay, so suppose you don't have the key pair and you create the key pair and you download it to your local machine. So once after that, how to log in, I will come to it. Right. And now there are some other important factors such as the EMR service role and EC2 instance profile service role. Okay, so EMR service role is a service role which will allow you, or which will have the policies that will allow you to logging into the EMR cluster as a whole. And EC2, since EMR service is nothing but an ensemble of EC2 instances, right? So in order to connect to the cluster, you also need an EC2 role. So the EC2 role for each and individual node, even though you will be logging to the edge node. So that is an EC2 instance itself, right? So one is for Amazon for the cluster, and the one is for EC2 instance, that is for the edge node. So these two roles needs to be set up. So by default, I already have one. If you don't have, you can simply create one and then add it over here. Again, these are all things which are not required to maintain for the data engineer. This service role, policies, attachment, and everything, it comes under the admin team or the platform team. They will take care of all the access or the permission related thing stuff that you need, that you require when once you get into the project. So no need to break your head onto how to create this service or how to attach these policies. You can just simply follow the AWS console and you will automatically understand. Otherwise, if you don't have, you can simply just, I mean, by default, it will be provided one to you. You can use that. Okay. So that's all about it. I'm gonna click on the clone cluster, and now the cluster is in starting mode. So it takes a bit of time to start. So once the cluster is properly created, in that case, you see the SSH and the SSM link over here. So that hasn't been published over here. It means the cluster is still starting. And if I just hover over this whole page, so it kind of gives you the summary or all the factors that you chose while creating the cluster. So these things have automatically come. And so yeah, my cluster has been successfully created, is showing, but still the SSH link hasn't come up. I'm just waiting for the SSH link. When it comes up, then I'll be able to. Okay, so now the SSH link has come up. So what I'm gonna do, I'm gonna click on it, and it will provide me the instruction on how to log into the cluster. Okay, so there is one Windows and there is one Mac Linux. In Windows, there's another way is you can just download putty and then you can have the .ppk file load into it, but it's a lot of hassle. With the latest version of Windows, these things are not required. It was required in the previous older version of Windows. With the latest Windows 11 or even with the Windows 10 later ones, you can copy this Mac or Linux command. All you have to do is just point to your download folder where you have kept the .pem file. Okay, so now I have opened one terminal. You can go for the command prompt or the PowerShell, and I will go to the downloads folder because that's where I have kept my .pem file, the key pair which is required to log into my cluster. So I haven't logged into my cluster. This is again, it's just a PowerShell that is running in my local machine, and I will simply paste the statement over here. So that is SSHI, then dummy key PEM. So this dummy key PEM is the dummy key, the key pair .pem file which I downloaded or which I created. And if you see this one, this is nothing but actually it is the host IP of the master node. Okay. So now since it is lying in my dummy, it is now in my download folder. I can simply omit this one and so that's it. This is my EMR cluster and I have logged into it. So let me check if my Hadoop is running. So if I do JPS, right, yeah, so my Hadoop is running and let me check if I can access my S3 bucket as well. So before that, I need to go to my S3 bucket and check if my script is there. So I've opened the bucket into another page, another tab, and this is the dummy bucket that I'm using. Okay, and inside over here, this is the script I'm gonna be running. The friends age data frame, the same one that I ran in my lookup. So there are two ways I can do it. I can simply just copy it to my Hadoop and then run it, or I can run it from the S3 URI as well. So I will try to copy it just to show you that how the copy command works over here. So let me just copy this S3 UI and first check if the file exists. I mean, if my EMR cluster can access this file. So using AWS S3LS, so this will list out if the file is there in this S3 bucket path. Yes, it is there. So now I will try to download it to my H node or to my master node. So to do that, I will simply put AWS S3CP, then the full file path along with the S3 bucket, and this is going to be in the root folder root path. So I'm going to put dot, and this will download. So if I do ls minus l over here, I can see the script has been downloaded. Okay. So the next step is I have to check with if my Spark is up and running. So I will try to open a PySpark console and let's see if that works. All right. So the Spark is up and running as well. I can try to run any command I want just to see if the Spark session is available. It is. So I'm going to get out of it and I'm going to simply submit my job using the input path. So if you remember when we ran the script in a local, it was taking the argument, the input path as one of the arguments, right? So it will try to read the file from the path that I provide. So over here, I'm putting the file in this CSV folder. This is the friend CSV that I need. This is going to be the input file, okay? And I will just copy this S3 path and then run my Spark submit script. The script name is friends, and I will feed in the input path, the input file path as the argument. So just paste it over here. Okay. So no need to put the whole file here. Even in the CSV path, there is only one CSV file that I need my PySpark script to run. So I'm just gonna put the folder path over here, and then press enter. So I have submitted my job into EMR cluster. Now it is running. Let's say this gives me the same output. Okay, there is one error. Let me see what's the error. No file system for Scheme S3. Because S3A API, which works with the Hadoop set. Let me check. Again, I'm having this error. Error occurred while calling Java class not my class or the S3 file system not found. Okay, so it is not able to read from S3. Not sure what's the reason. Let me try with the. Okay, I believe that the yarn is still not up and running. I mean, not all the services are fully up and running, and that is the reason it's causing this issue. Because I see it is trying to connect to the server and it's failing, like it's doing some retry. So it may take a time. It may take a bit of time to kind of like start all the services, and then only I'll be able to run my job smoothly without any errors or issues. So let me just wait for a bit. Okay, so I have waited for some time and I hope it is up and running now. So I'm gonna try again by running it. So I'm gonna keep the same command and press enter. Yeah, I see now it has been accepted in the end with the application ID. So it should be good now. So there it is. So the output has come now. One was the data frame count, that was 301, and the other one is the group by age and the number of average friends that each and every age group has. So the output has come. So my Spark job is running fine. Now let me take a look at Hive and how it looks. So I can access the Hive over here. I can just simply type Hive and I can get directly to the Hive console. Let me check what all the databases are available for me. Okay, there's only default. So not all the databases that are from Athena are available. So I can create a database and I can start working on it. But at the moment, I'm not gonna show you any table demo because those are already covered in the Hive session. So that's it from me. My requirement was to submit a Spark job from here, and I was able to do that using Yarn, and also I'm reading the data from S3. So that's pretty much it from the AWS cluster. So what I'm gonna do, I'm gonna shut it off. So shutting down a terminal isn't really shutting your shutting your EMR cluster off. In order to totally terminate your cluster, you just have to go over here, EMR on EC2 cluster, click on it. Just click on the clusters which are waiting period, waiting means it's running, and just click on this, just click on the check, and then you click on terminate. So this will terminate the cluster, and this will ensure that your cluster is not up and running anymore. Because if your cluster is up and running and you simply just get out of this console, that means your money is getting heavily wasted. Okay, because it works, it will start billing by the hour because your instances are still running. So if you just left it open and close your browser, in that case, you'll be in deep trouble. So make sure whenever you're starting any services, not only EMR cluster, you make sure that you terminate the services when you are not required anymore, just to ensure that it doesn't really cutting money in from your bills. Okay, so that's all about it from AWS EMR. So that's how you can create a cluster. You can submit a Spark job, and you can simply uh, play along with it. So not only Spark, but Hive, Hadoop, everything is available for you. So you can just run any sort of data processing framework over there using PySpark and Hive, and you just have to pay for an hour how much you need. And if you see that there's no such of hassle in setting up a cluster, right? Everything is managed and provided by AWS. Whereas in local, if you want to do anything by yourself, in that case, you have to do a lot of stuff in order to achieve the same cluster setup. So that's all about it from this session. So do reach out to TechSpark in order to get more clarity regarding our data engineering course. We cover almost all the topics regarding Spark, Hive, AWS, and then we also provide hands-on coding and some real-world project. Just reach out to us in case of any issue, any concern, or any clarity. Thank you.
Contact us for the free job assistance. We will help you to get the IT job. Please like, subscribe, and share the channel for more regular updates from TechSpark.